In the previous video, we created a React app from a simple set of requirements, and we saw complexity creep into the project to improve the user experience. We managed this complexity, but not without battling subtle bugs that arose from implicit state in our application. Future developers and even ourselves in 6 months will have to continue to manage that implicit state as features are added over time. In this video, we're going to re-implement the requirements in a new app using Statecharts and see what benefits that they may give us. So let's review the requirements. The page has a button labeled Get a Laugh. Once the button is clicked, the comic is loaded and shown. If the button is clicked again, a new comic is loaded and shown. The counter keeps track and displays the number of laughs requested during a session. So let's implement this now using Statecharts. We'll clean up kind of like we did the last time. Copy in our common code. We want to install a couple of additional packages here for Xstate. Okay. Okay, when we start this one, we're gonna immediately see a different flow. We're gonna start with the machine itself. Okay, so we're going to define our machine. The machine just really describes the operation of our system. What does a machine have? So we know a machine has a set of states. We know that there's an initial state the machine starts in. Well, what is the first state it's in? Well, it's kind of what we see over on the right. So that's kind of our first view. For lack of a better name, let's just call it first view. Okay, and that's going to be our initial state. Okay, what other states can it be in? Well, we know that at some point we're going to show a comic. Let's go ahead and add a comic view. That's another state the system can be in. How do we get from here to there? Okay, well, we click the Get a Laugh button. But the Get a Laugh button doesn't take us straight to viewing a comic. We have to go load something first. So let's add a loading state. Okay, so that's a reasonable set of states. So we have the first view, click a button, we go to loading, something happens, and then we go to the comic view. So how do we get between these states? Well, from the first view, we've already said that if we click a button, then we should start loading. So we can implement that with the on handler. So when we get to the loading state, we need to take some action to load our comic, namely making a fetch call. We know that fetch returns a promise, and promises are actually state machines themselves. They have 3 states: pending, resolved, and rejected. Xstate knows how to invoke other state machines and recognizes promises as state machines. So, when we get to the loading state, we can invoke our promise returning fetch function as if it were just another state machine. If the promise resolves, it'll send the onDone event to our state, which we can handle here. If it rejects, it'll send onError. So if we get a good load, what do we want to do? We want to go on to the comic view. if we get a bad load or an error, what should we do? I guess we should add an error view. So if we're in the comic view, how do we get out? Well, the requirement said we should load another comic if the user presses the button again. So we can just handle the same get a laugh event that the first view did, and we want to do the same thing in error view. Already, we've designed the whole flow of our application. How do we go from here to actually having it work? Well, a couple things are missing. First, there was that counter for the laugh requests. Also, we need to know the comic image path, and we need to keep the error message for display. To store data that doesn't directly drive the state of the system itself, Xstate provides an object called context, so we'll use that. For the fetch counter, we want to update that basically every time we go into the loading state. So we can add an action we'll call increment fetch count as an entry action to the loading state. When a comic loads successfully, we want to store it. We'll add an action called store comic to onDone. Likewise, for errors, we'll add an action called store error. Now, these actions will be called when the transitions happen. Now, you'll notice we use strings for the actions. This provides good readability when you're examining the machine. We can define them in a secondary object that's passed to the machine constructor. Sign is a special action provided by Xstate that lets you set variables in the context. You pass it an object containing the keys for the context you want to set, and each key's value is a function that receives both the current context and the event that caused the transition. Whatever you return gets stored in that context variable. The only thing missing is that fetch call to load the comic. Xstate refers to things you invoke as services, so let's add that as a service. Okay, we pretty much designed the whole system and we haven't written any React code yet, so let's do that. We'll start pretty much like we did the last application. Okay, that's our shell. It's not hooked up to anything, but should work. Oh, let's import styles. Oh, I forgot to change those class names. Do that real quick. Okay. Okay, so it's working. We just haven't integrated it with the machine yet. Let's do that. This is how we integrate the machine. State is an XState object, not to be confused with React or Redux state. Send is how we send events to the machine. So first, let's print the number of laugh requests. Remember, this is now stored in the state machine context, so we can get it from there. Now, I could destructure that, but I'm going to leave it in the full path so that you can see where it comes from. Okay, next let's send our get a laugh event on the button click. Easy as that. Now let's display the different states. What do we want to do in the first view? Show that click the button text. What about when we're loading? Ah, the loading spinner. And what about the comic view? That would be the comic itself. And finally, the error message for the error view. Let's load our loading spinner. Okay, let's try this out. Their comic, and click multiple times. Not requesting anymore. Comic. There's our error. Error. Comic. Looks like it's working. Now this is the same system as before, but we didn't hit any of those subtle bugs like the first implementation. Remember things like the error not getting cleared and the multiple requests if someone spams the button while it's loading, and so on. But why not? Well, there are a couple of reasons. First, the process of designing the machine up front made us think of things earlier in the process before we wrote display code. We discovered during machine definition that we needed to show one message at the start, show the comic if it loaded, and show something else if an error occurred. We didn't have to worry about the error message being cleared at the right time because it only matters in the explicit error state. We didn't have the multiple request on button spam error because the loading state is explicit and does not have a handler for the get laugh event, so that event has no effect in the state, and you can clearly see that in the machine definition. Personally, that alone is enough for me to want to implement my UI logic in state machines. But wait, there's more. Let's say it's 6 months later and someone asks you to explain the system to a new engineer or maybe a product manager or someone who's not familiar with code or even coding in general. You could do it in both versions. In the first, you'd be jumping around to various bits of logic embedded in UI code and maybe explain what each of those state variables are for. The second, you could probably get away with just showing the machine object and tracking the flow through there. It's certainly nicer to look at, but what if you did this instead? So the system starts this first view. You click get a laugh, it goes to loading. When you enter loading, increment fetch counter is called. That updates that laugh request item. Once this is loaded, you invoke fetch laughs. When it's done, it stores the comic, goes to comic view. If it errors, it goes to error view, storing the error. In either state, if you click get a laugh, it goes back to loading and starts the cycle again. For me, that's certainly a lot easier to look at, follow, and understand. And it comes straight from the code itself. It's not an out-of-date document. Or even better, we install the dev tools. We can demonstrate the flow in the machine while we are using the application. That's pretty cool. Another benefit of having the logic in the machine, if we wanted to switch frameworks to say something like Vue, all we'd have to do is rewrite the small bits that display the current state of the machine and inject events into it. Everything else stays the same. We've just scratched the surface of what Xstate is capable of, and of course our sample app is not a large application. We saw, however, that even small apps can have complexity. We also saw that Statecharts can mitigate some of that complexity while helping us visualize the system as a whole. The next time you start a UI project, I encourage you to give Statecharts a try. That's all for this video. Thanks for watching. If you like this video and would like to see more, please consider subscribing to my channel.